Warm greetings to all. In this subject, we are going to discuss on the topic of radio receivers. Radio receiver is an electronic device which picks up any desired radio frequency signals and records the baseband signal from it. So in this diagram, here we are going to give the input signal as an audio signal, which will be converting to an electrical signal by using the transducers. So from the transducers, it has been converted the electrical signal. It has been transmitted by the transmitting antennas, which will be converted into an electromagnetic waves, which will be transmitted in the free space. So in the receiving section, we'll be picking the electromagnetic signal, and it can be converted to an electrical signal by using the transducers, which will be received by the receiving devices, which can be recovering the that is a original baseband signal. So this is a function of the radio receivers. So first of all, we are going to cover the AM receivers. So what is the main function of AM receiver means it converts the AM modulated wave to an original message signal. So that there are different types of receivers are possible. First of all, we are going to see what is tuned radio receiver and super heterodyne receiver. First, we can focus on what is the main function of the receivers. This main thing is it can do the function of interception, selection, and it can perform the RF amplification. It also deduct the signals, and it can perform the audio amplification, and it also do the reproduction process. So interception means it is a function performed by a receiving antenna. So the waves, that is the radio waves which is coming from the transmitting antennas will be picked by this antenna. So where it can be converted and is here that is it can be received by this antenna, and by this is we can call as interceptions. So after receiving this signal, the voltage will be induced in it. So we can say it as a single antenna will be intercepts radio waves of all carrier frequencies. Selection. Selection means we can able to say that the receiver can select a particular desired frequency, carrier frequency, and can able to reject other remaining frequencies. So for to perform the selection process, a tank circuit has been used. Tank circuit means we can call it as it is a resonant frequency of the circuit, which can be changed with the help of the capacitor and inductor. So we can say it as a large number of modulated carriers from various transmitters is intercepted, and we can able to select only a one frequency will get selected. Next, we can perform the RF amplification. So after selection process, the selected carrier frequency will be amplified by using the class of C-tuned amplifier. So what is the necessity of this amplification process means which will be used to raise the voltage level so that we can able to operate the this we can able to make the circuit to be operate in the linear director following the stage to operate in the linear region. So we are going to improvise the voltage level and we are going to increase the strength of the signal. So by using this, we can able to increase the carrier voltage, which can be able to suppress the effect of noises. So next process will be a reduction. After recovering, it is a process of recovering a baseband signal from the modulated carrier. After reduction process, there will be having a stage called it as audio amplification. The director audio signal will be further amplified in order to increasing the level of the strength so that it can drive the speaker. So for this stage, we'll be using the RC coupled amplifier followed by a class B push amplifiers will be mostly useful in this amplification process. Next stage is reproduction. Reproduction means we can say it as it is a process by which the electrical signal will be converted to a desired physical message. So according to the person, how we will be providing, for example, for communication side, we'll be using the speakers. So after recording the audio signal, it has to be converted to an speaker signal. So that is we can say it as in commercial broadcast receiver, the output of the audio amplifier fed to the speaker that produces the sound. So the sound signal will be produced from the input audio signal. That is call it as reproduction process. So this is the functions of AM receivers. Next, we can see what is the characteristic of receiver here. So main characteristics are selectivity, sensitivity, and fidelity. Selectivity means we can say it as it is a receiver's ability between two adjacent carrier frequencies. If you see the diagram here, so here we are going to have, will be represent the say, resonance curve of a tuning circuit. So here the receiver will be able to select the particular desired frequency and will be almost rejecting the all other remaining frequencies. So the based on the resonance curve here, we can able to say what type of signal it has been obtained, how the frequency has been selected. So the selectivity will be depends upon the sharpness of the resonance curve of this tuned circuit which is involved in the receiver. So based on the sharpness of the resonance curve, we can able to give a suggestion that it has done the very good job of selection process. So we can say it as if you are obtaining the curve as a sharper, we can say that the selectivity is better. So better means it's going to it has performed the process of rejecting the undesired signals and it selected a particular range of frequency alone. That is a thing which is happening in the selectivity process. So the sharpness of the curve will be depends upon the Q of resonance circuit. Q means it is a quality circuits. So the quality factor increases, the selectivity will be increases here. So as we know that we have know the formula for your quality factor. Q is equal to Fc divided by bandwidth. Fc is the center frequency. So if the quality factor increases, the bandwidth will be decreases. So if we have the sharp curve, we can say it as bandwidth will be, if you have narrow sharp curve, we can say it as bandwidth will be decreases. If you have if you have less sharpness of the curve, we can say it as bandwidth has been increases. So from this formula, we can able to relate what has happening in your selectivity process. So next thing is sensitivity. Sensitivity means we can say it as it is the ability of the receiver to detect the weakest possible signals. So it has the ability to detect your weakest possible signals. A receiver with good sensitivity will provide you more output. The sensitivity of receiver is detected by his gain of his amplifying stages. Next one is fidelity. Fidelity means it is the ability to reproduce the exact replica of your transmitted signals. So it can able to generate the what is the signal which has been transmitted. So it has the ability to reproduce the exact replica. So that is we can call it as fidelity here. So as we know that there are two types of receivers are possible. So tuned radio receivers and second one is super heterodyne receiver. The first thing we are going to see what is TRF receiver. Otherwise we can call it as straight receiver. So this is a block diagram of TRF receiver. So here we're having the receiving antennas, and next stage we'll be having the RF amplifier, and the second block diagram represents the second stage of the RF amplifier. From that we'll be have reduction, audio amplifier, power amplifier, and loudspeaker. As we know what we have studied in the function of receiver. First, it can be the antenna, the receiving antenna will be pick the electromagnetic signal. From that, it has been captured by the RF amplifier, and from that, after amplification, it has been detected by the detector process. And next, it has been given to the audio amplifier. And next, it has been processed by different types of power amplifiers, which can be convert your audio signal. And the next stage will be a loudspeaker, where we are going to convert your audio signal to an sound signal. So in this tuned radio receiver, here we don't have any mixing of frequencies. First, the incoming signal which is coming from the antenna will be first amplified in one or more tuned RF amplifier stage. So in this thing, we are going to increasing the magnitude level of your signal, and it will be improves the sensitivity of the receiver. Then the amplified signals are then fed to the detector to obtain the original modulation frequency signal. After modulation process will be having the amplifier. So where the modulation frequency will be further amplified by the audio amplifier. So one main drawback which is possible in your tuned radio receiver is here with too many RF many stages here, the circuit becomes too selectivity because since we have two stages of RF tuned amplifier, the circuit becomes too selectivity. So as selectivity will be decreases as the carrier frequency has been increases. So this is the two main drawbacks which is possible in your tuned radio receiver. So the limitations of the tuned radio receivers is overcome by the super heterodyne receivers. Heterodyne means we can say it as mix. It can simply change or translation of the carrier frequency is going to be happen in the heterodyne receiver. So in another words, we can call it as it is a frequency translation. This frequency translation is achieved by mixing the carrier frequency with locally generated frequencies. So the carrier frequency we can be mentioned as FC and local generated frequency as FL. So the mixer is also known as first detector here. So what is the main function of this mixer means it will be generate the sum and difference of carrier frequency and local oscillator frequency at the output. Next, after mixing it, we'll be having plus or minus of frequencies. So we can say it as sum and difference. So the difference of frequency FL minus FC is selected by properly tuned circuit, and this frequency is known as intermediate frequency, that is mentioned as FI. Super heterodyne or double reduction receiver. So here the frequency conversion is going to be takes place once before the reduction. That is, we can call it as super heterodyne or double reduction. If the frequency conversion takes place twice before the reduction, then that is we can call it as double super heterodyne or triple reduction receiver. So usually the intermediate frequency for commercial radio receivers will be usually fixed to 455 kilohertz. So next we can see what is super heterodyne receiver. So in this block diagram, we can see here we have receiving antennas, and the next stage will be an RF amplifier. Here, what is the difference which makes the super heterodyne receiver to the radio receiver means that is tuned radio receiver means here we are providing a mixer. For the in TRF receiver, we don't have any detectors, there is mixer circuit. So directly will be given to the, will be have only the two or three more stages of RF amplifier. We don't provide any local oscillator at all. But here we'll be providing two mixer stages. The mixing will be possible here, and then we'll be proceeding towards the detector. And next it will be given to the amplifier, and it can be proceed towards the captured by the speaker. So this is the thing which is happening in the block diagram of your super heterogeneous river. So here we are going to be combine the RF signal frequency to the local oscillator frequency, that is FL, and RF is there is a signal which is received by the receiving antenna frequency will be an FC. So both the frequency will be mixer can be mixed. It can be called it as a detector circuit. So where it's going to generate the sum and difference. So that is frequency we can call it as intermediate frequency as FI. So it can able to generate the sum or difference. So we can going to be select only a difference of frequency as FC minus FL, which can be obtained by using the tune circuit by the there's a IF amplifier. So that can be captured by the second detector, and it can be obtained the frequency has been obtained that can be given to the voltage amplifier and captured by the speaker here. So in the RF amplifier stages, we'll be using the Class C tuned amplifiers. So by mainly the amplification process of this radio frequency is used to provide a better sensitivity and also to improvise your signal to noise ratio. As well as we can able to reject the unwanted signals. So the rejection of image signal will be possible. So what do you mean by this image signal means we can say it as a signal whose frequency is FC dash is above the local oscillator frequency by same amount as desired frequency. So as we know that FL minus FC is equal to FI. So from that we can able to find what is FC here. FC is equal to FL minus FI. So FC is below FL by an amount of Fi here. So that is we are going to find what is the image signal. We are going to choose the image signal frequency as above the local oscillator frequency by the same amount of Fi. So we can find we can express the image frequency as FC dash is equal to FL plus Fi. So from that expression, we can directly substitute what is FL here. So from the previous diagram, previous expression, we can substitute here FC dash is equal to FL plus Fi. So it can be proceeded towards here as, so FL can be replaced as FC plus Fi. So after substitution, we'll be getting the answer as FC dash image signal frequency will be equal to FC plus twice of Fi. So that is the same expression which has been given here. Usually, the image signal frequency will be can be cancelled by the intermediate amplifiers. So the image signal frequency will be FC dash is twice of Fi more than desired signal frequencies. So what happens means here this spurious FC dash signal also amplified by the IF amplifier and produces some interference in the receiver output. So we have to provide some tuned circuit at the RF amplifier stages to attenuate this image frequencies. So the next stage of first, we have seen briefly about RF amplifier. Next, we are going to discuss what is a mixer. As we have gave the outline of what is a mixer operation here. But here we are going to be include a mixer means it is a non-linear device which will be performs the sum and difference. So it's going to generate the FL plus or minus of FC. So the desired intermediate frequency will be selected by using this tuned circuit. So based on the tuned circuit, that is, we can say it as the intermediate frequency transformer will be perform those operation of the tuned circuit by using the inductive tuning circuits. So this is a operation which is done by the mixer circuit. Here we'll be having in FC frequency and FL frequency, and we are going to generate the FI, that is the intermediate frequency by the transformer here, intermediate frequency. Usually the mixer will be classified as two types, that is separately excited mixer and self-excited mixer. What do you mean by this means? A separate devices will be used for mixing and generating the local oscillator voltage. In self-excited mixer, a single device will be performing both the mixer and local oscillator. That is, we can call it as frequency converters. But this diagram will be represents the separately excited mixer. So this is a diagram which shows a self-excited mixer here. So if you see the diagram here, here we don't provide any RF amplifier stages in the receiver. So the incoming signal from the transmitter will be directly given to the transmitter. Here, after giving to the transmitter, and there is a a transistor, local voltage. That is, we are going to directly give the signal to the transmitter. So what happens means a local oscillator voltage will be developed from here by using the tuned circuit capacitors, that is we can call it as the capacitors which are ganged together to provide a single dial tuning here. So the capacitors which is present in the tuning circuits will be connected, all the capacitors will be connected together by having the control over a single knob. So since it has been ganged by a single knob here, the front end circuit, that is RF circuit and mixers, are tuned to the incoming FC here. So local oscillator has to be tuned to a frequency higher than FC by Fi. So the local oscillator will be generating a frequency of intermediate frequency as Fi is equal to FL minus FC. So the tracking should be done at the two different matches of the intermediate, the 2 points along the dial. So there's some errors will be possible. That is, we can call it as tracking error. So we have to provide some alignment of the precise alignment we have to do at the tune circuit to achieve the zero tracking error at the 2 points. That is, we can call it as 2 point tracking. Possibly, we can able to precisely align the tune circuit at 3 points along the dial by including another circuit, that is we can call it as series capacitor and shunt capacitor. That is, we can call it as trimmer or padder, which can be provided here to provide a 3 point tracking method. So the local oscillator here, we can which is can be kept higher by the FC by Fi for the following reasons. What are the two main reasons for keeping the local oscillator higher? First, in order to achieve the maximum to minimum capacitance ratio of the two sections should be of the GaN capacitor should be quite close. So we can say it here as we can find the ratio of C max divided by C minimum is equal to 9:1. So since we have chosen the for medium wave, we have taken 550 kilohertz to 1650 kilohertz. So we are going to make a ratio of the value as 1650 divided by 550 the whole square. So we are getting the ratio as 9:1. So while FL is kept higher, the ratio will become as 4.4:1 here. So based on the adding of the 455 intermediate frequencies. So adding the four intermediate frequencies to both the C max and C minimum here, we obtain the ratio as 4.4:1 here. So if you are going to keep the kept lower value of the local oscillator, so we can able to subtract those values and we are going to obtain the ratio as 156 to 1 here. The next stage of the mixer, as well as the next stage of the local oscillator stage, will be an IF amplifier, where it's going to be providing a tuning of the voltage amplifiers in order to provide most of the obtain a good receiver gain. So more than one stage may be used to improvise your sensitivity. So for commercial AM receivers, we should have choose the intermediate frequency as Fi is equal to 455 kilohertz. So for image rejection, Fi should be have the value as should be large, and it should have the image frequency as Fc dash is equal to Fc plus twice of Fi. By taking the ratio of this here, we are getting as 1 plus 2 Fi divided by Fc. So if Fi is kept large, the image signal can easily be rejected. So we can say it as the image signal rejection become poor due to double spotting. So the double spotting can be avoided by having a good selectivity to reject the image signal. So this is a detector stage where we'll be using the linear diode detector. It is a simple circuit as well as a low cost. So to keep the receiver output constant with time for any variations of the input voltage, we are going to provide an automatic voltage circuit bias is going to be provided from this stage. So any variations in the input voltage due to fading or any receiver is tuned from one station to another having different signal state, we can able to use this automatic voltage circuit which can be controlled the eliminates the effects of these variations. So this is a second detector here. So the variations can be controlled by AVC circuit here. And next stage is audio amplifier where will be providing a push-pull amplifier circuits. So we can able to say that the fidelity of receiver is determined by the frequency response characteristic of this stage.